Okay. So what I will do is I will go through the complete process of how we create any kind of machine learning model, and this whatever I'm going to tell you, this is going to be the general process in any kind of machine learning process. What we will do. Okay. Now I had solved one problem, so I will use that. So I didn't spend time on creating a new problem and things like that. But I think this can help all of us to understand. I will also tell you where are the places where we will have to make some changes in our strategy. And please feel free to ask any question so that I will also learn from the questions, whatever you have got in your mind. I may not have all the answers, but I will try. Okay. Now here I have a data set. This is a data set taken from NASA. Okay. Now what they have got is they have got 5 attributes. This is basically for a wind turbine simulation project. Now you see the kind of utility what these kind of projects have got is that if I have to um, do this project physically, then I'll have to set up the physical system where I will have to change the attributes like the frequency, the attack angle, chord length, etc. physically and then make the simulation. So you can understand how expensive that's going to be. Now, supposing I do this kind of experiment about 1,000 number of times by changing the physical attributes, and then I make simulations of make a machine learning model to do predictions based on this 1,000 experiments which I've conducted, then I can keep on kind of kind of estimate what can be the nature of the output based on different parameters that I will give. So this is the value what such kind of projects bring, like to big organizations. So you can imagine how much amount of dollars will be saved by such kind of projects. Anyway, so here we have, from our perspective, look at it as, like I told you, we will have data in the form that we will have A, B, C, D, E, and we will have one variable which is the y, which is the one which is the dependent variable which we would like to predict. So here we have 5 variables. So these are the 5 variables which is the data which we have got, and we have recorded based on this variable what is the output that we are getting for a 6th variable which is our y variable. Okay, so this is what is the data we have. So if you equate to our situation, we will have more than 6, we will have hundreds possible of variables regarding different attributes of the malware files, and we will have one output variable, that is the whether the file contains a malware or file does not contain a malware. So that is going to be our data. Now there is a little bit difference between our problem and the problem we are seeing here, that in this case this y variable is a continuous variable. So from our yesterday's discussion, we understand that for a continuous variable, what we can do is we can do a regression to find out what will be the value, right? So in our case, in the malware detection case, we will have to do a classification to find out whether the file contains a malware or does not contain a malware. So, but that's a very minor difference. That will not be much problematic. Now, in any case, we will have the data. In our case, also we will have the data. I will soon share. Maybe by tomorrow, I will share you uh, regarding the JPEG files. I have made a strategy. I will discuss that with you. Maybe today, if you want, I can discuss that today also. Maybe tomorrow we will. I will send you by tomorrow. After that, we can discuss. That will be better. Uh, we will have a file containing data. Now, the first step is that we have to import. We have to import the file into the program so that we can start processing it. There are some libraries. All these things, if you want, I can take a session later on and explain to you basic Python in case, but I'm sure you know this things already. So now here you see I am reading the data. So there is a library called pandas which reads the data. 1 minute. This is the file doesn't happen to be here, the data file. So I'll just import it. It is not a bug. It is just that the file is not there. Okay. Just give me a second. Here for I've forgotten where that file is. Yeah. Okay. Now that the file has come, so if I do this, it just uploads the data. You see here. So here I have got, like I've said here, there are 6 variables. One is the output variable, and remaining 5 are the input variables. Now this data file, if you notice here, this data file does not contain any header. But I know what each of this data is content is all about. So I can create the headers programmatically and say this is what the data means. So now I have the data in the format that I require. But this is all normal. Everyone who all of us are programmers, so we know this is not normal. This is not very difficult. Now we can see how much amount of data we have got. So you see here I have got 1503 data in 6 columns, right? So we will, in our case, we will have around about 20,000 records or something like that for the malware detection. Okay. Now, for one of the things which we will have to do is, you will notice that in our case also, the data what we get will contain a lot of noise. That we will have a lot of data which is missing, lot of data which is wrong. Fortunately, in our case, one of the things which will not happen is that we will not have any data which will be erroneous because of data entry problems, because we are not entering any data. We are all the data is contained in files, and we will just take the files and read the data. So unless our program makes a mistake, there is no chance of any data being wrong. So that is the advantage that we have. But in any case, we will have data which is where there are a lot of missing data, etc. One of the things we have to do is that we have to take a decision regarding how to treat the missing data. Now in this case, you notice that there is no missing data, so all data is fine. So we don't have a case regarding missing data. Now, when we have missing data, what we will have to do is we will have to take a strategy. In some cases, we may say that if the number of records which is missing is very small compared to the total number of records that we have, the easiest strategy is to remove those missing records, records with some missing data. That is the easiest strategy. That takes least amount of time. However, if the number of records with missing data is too many, then we may have to take a strategy. Let's say sometimes what we do is that we replace the missing values with the mean value of that column. So that is some it has got merits and demerits. We can go into the theory later, but that is one strategy. Or sometimes we say instead of mean, we will take the median value and replace the missing data with the median value. So there are different ways of treating the missing data, and we can take a strategy as to how to do that. But in our case, we will have a situation where we have a lot of missing data, when we will have to work out a strategy how to deal with the missing data. Okay. After that, after we have the data in place, we will have to do visualization of the data. So here you see I'm doing a visualization of the data where I am creating histograms which basically show the distribution of the data. So here I've created histograms of all the variables. Now, one thing you notice in this case, very significant, is what is coming out is that you see the first 5 histograms are for the independent variables, what I have got. And the 6th graph is for the dependent variable. Now, we can make a conclusion from this graphs very easily is that you see that the distributions are all haphazard for the independent variables. But that means at random, I'm giving the values of the independent variables. In spite of giving values of independent variables at random, the output, the distribution of the dependent variable is like a normal distribution. That means to say this data has got a very good chance that it will make a good prediction based on the inputs what I'll provide. Because no matter what is the combination of inputs that I'm giving to this data, it is kind of giving a predictable. Now you understand the normal distribution means it is falling into some kind of pattern. Because in statistics, we say there is a theory called law of large numbers. Law of large numbers basically say that any distribution, any experiment, if I conduct that experiment a large number of times, then the experiment result will tend to be a normal distribution. If you want to understand a law of large numbers in a layman's term, it is like this. Let's say when you're playing cricket, we say that if a batsman is scoring hundreds after hundreds, we say that now it is very likely that he will score a low score in the next match. Or if a batsman is scoring low scores, we say that he's likely to make a big score in the next match. That is because we say that sometimes layman term we say law of averages is catching up. Actually, it is not law of averages; it's actually law of large numbers, where all distributions, if the experiment is conducted large number of times, it will tend to become a normal distribution. That happens, except in few exceptional cases, like sometimes it becomes a Poisson distribution or something like that, but they're exceptional cases. Okay. Anyway, from this data perspective, what we have to basically do is that we have to analyze the data and find out whether we are getting a pattern which can help us in making predictions. In this particular case, you see that since the output variable is giving a kind of normal distribution, so we have a good chance of making good predictions from this data. Okay, once we have done that, we can do something more also. We can do some more visualization, and which we will do. We will do a number of them, and here I'm only showing you a few of them. Now here I've created box plots for each of the variables of the independent variables. So box plots we create basically because to find out whether we have any outliers or not. Now you see that in the first chart, that is attack angle, there is a clear outlier. Now this box plot, how it works is that the central line, what you're seeing here, this is the median, and this is the third quartile, this is the first quartile, and these two lines are the 1.5 times these are known as the Tukey's boundary. So anything which lies outside these two lines, these are the whiskers, anything which lies outside the Tukey's boundary are known as outliers. That is, they are 1.5 times more than the interquartile range, right? So anything which is an outlier is a problem, because let's say, for example, you are analyzing the salaries of people, right? And you include the salary of Bill Gates in that. So obviously what will happen is that Bill Gates' salary is so huge that it will drag the mean towards his salary, right? So if you include Bill Gates' salary, then you will seem like the average salary of the group is very high, which is wrong, which is not a correct representation of the data, right? So we will have to take out the outliers so that the data representation is correct. Now here, in our case, we will not have much of a problem with this because, again, the chances of outliers entering our data is very little because we are taking practical files, and the chances that we will have outliers is very minimal. But nevertheless, we will have to analyze the data to find out whether we really have outliers and whether we require treating outliers or not. So we will have to do that exercise. Okay, once we have that, then now you see here, what I'm doing is that I'm treating the outliers where I say that only 30 rows are there which contains the outliers. So I'm just removing those rows and keeping the remaining 1473 rows for my analysis. Okay. Now comes a very important point in our analysis, that we need to find out the correlation between all the variables in our data set. This is a very important step because I will tell you the reason why this is important. Now you see that I have taken on the correlation between the dependent variable and the independent variables. Now, apart from this, we will also have to take a correlation between the individual independent variables also. This step is very important because in data analysis or in machine learning, if we have variables which are highly correlated to each other, then what will happen is that, supposing two variables are highly correlated to each other, then both will tend to show the result in the same direction, right? If two variables are very highly correlated, they will show the result in the same direction. So if I have variables which are highly correlated, instead of one variable influencing my decision, two or three variables or maybe more than that variables will try to influence my decision, and the decision will become biased in that direction. So what I have to do is that when we find out our independent variables, we have to take out the independent variables which are very highly correlated and only keep one of them, which is the strongest among them, in the set, so that it does not cause any bias where my decision is going to favor in one direction over the other direction. So this is a very important step, and we will have to do this analysis very carefully so that we do not introduce any flaw in our model intrinsically by our poor decision making. Okay. Okay, now once we have done that, we will take some more steps also. This is a simple data set, so I did not do too much. We will discuss more, some more steps what we can take in terms of analyzing the data and then getting the right data set. Now let's say that we have the correct data set and that now we start building a model. So this is the place where it will interest you. So now you see that you will notice very significantly that the amount of coding that we have to do in Python is very minimal. Okay, it's only that if you know what to do, you will get down to the matter very quickly, because the amount of code what is required is very little. Where we will require time is that these models to build themselves will require a lot of time, because all our machines are going to be small. Though my machine has got 64 GB RAM, still this is considered a small machine for machine learning purposes. Um, Sometimes but we do not have too much data also. Supposing we have data in terms of 1 million records and things like that, to build the model it can take 3 days, 4 days, 5 days also. So that is normal. So that is where our time will go. Okay, nevertheless, the first step what we have to do is that once we have the data, we will have to split the data into the test set and the training set. Why we do this is because we will train the model on the training data. Okay, after we train the model on the training data, we will see how much accuracy the model is generating based on the training data. Once we see that the accuracy of the model and we are satisfied with that, then we will test the data on the test data. Right, now test data, what is there is that test data knows what the outcome should be. Right, the training data also we knew what the outcome should be, and we are able to compare. Okay, fine, this was the outcome required and this is what is the model outcome all about. But while training, the model has seen the complete data, right, both the dependent variable and the independent variables. But in the test data, it has not seen the dependent variable at all. So when I give him the independent variable in the test data and I see the output of the test data, I can make out whether my model is performing well or not. That is a true test, which whether what do you call our model is going to behave properly and is going to be reliable or not. After we have done this, after we have trained the data on the training set and tested the data on the test set and found that our accuracy of the model is acceptable to us, then we will ask Anand sir for giving us some more files which we will test our model with. Now, those files will contain data which will not be seen by the model at all. So when we test our model on that data set which Anand sir will provide us, we will know for sure how reliable our model is. Right. Anyway, so the thing what we do here is that we split our data into test and training set. Normally what we will do is that the training set is going to be about 70-80% of the data and the test set is going to be the remaining 20 or 30%. So here what I'm doing is that I'm keeping 70% as the training data and 30% as the test data. So this is what is the variable all about. Now after I get my train test split, so here you see that I'm keeping the training data in one data frame, I'm keeping the test data in one data frame. What I'm doing is that from the y variable, I am keeping only the dependent variable. This is what I want to predict, right? So I'm only keeping this variable in my y. And for the x, I am keeping everything except for this dependent variable, because I will be creating my model based on the independent variables to predict the dependent variable. So in the x, I only keep all the variables except for the dependent variable, and in y, I keep only the dependent variable. Okay, once I've done that, so you can see here that in my training, I have got 31 rows, and in test, I have got 442 rows. Okay, so just to show you that, you see here in y, I have got only the independent variable, and in x, I have got all my, y, I have got the dependent variable, and in x, I have got all my independent variables, right? Once I've done that, now what I will do is that I'm making a linear regression model. You see here how little bit of code is required to make a linear regression model. I have to only import a library. Then I will say that, okay, here there is an important concept. That is, I am saying normalize the data. Now, you look at the data once again. Look at this data once again. You see here, frequency, the value is in thousands, right? Whereas attack angle value is in tens, maybe even units. Whereas chord length, the value is in decimals, right? So there is a huge disparity in the range of the values of each of the variables, right? So what will happen is that if I make the model based on this data, what will happen is that the variables where the values are very high, like the frequency, will influence the model very heavily. Okay, so the variables where the value is lesser, their influence in the model will be less. So the model's predictability or the capacity to predict correctly will become less. So what we do is that we will normalize the data. Normalization means what? We all have studied this in engineering. That what I will do is that I will take the value. Let's say this is the value x. I will say x minus the mean of all the values in this column divided by the standard deviation. X minus mu by sigma gives me the z. Now once I get a z, z is always going to be between what do you call, something like -3 to +3 or some, maybe -4 to +4, in that range. Majority of the data, we know that majority of the data will be within -3 to +3 because within 3 standard deviations we have 99.9% of the data according to the normal distribution curve. So once I have done the normalization, what will happen is that all the columns will contain data which is in the range of -3 to +3, maximum of them. So they are all compatible values. So the influence of each variable will become similar on my model. So that is what I want. So that no single variable should dominate my model and make the predictions wrong. So that's why we normalize. So I say normalize, and then when I say fit, this is where the model is created. Okay. So when I run this, now it is creating. So this is so now my model has got created. This is only 1400 rows, so it doesn't take time. But when we have more data, it will take a lot of time. This is the place where it will require a lot of time. Okay. So now my model is created. Now I can use this model to make a prediction. So you see here, I'm making a prediction. So for predicting, I'm giving the X train. I'm telling use the X train to make a prediction and get the predicted value of Y according to your model. So when I do that, it is produce the predictions. Now what I can do is that I can check how good the prediction was. So this is a regression model. So we can say that show me. So it says that the absolute error is 3.57, and the significant thing here is to see the R-square score. R-square score basically says that how good the model has been. So you see it's 0.54. It's not so good. So if it was something like 0.7, 0.8, it would have been much better. Nevertheless, so after we have made the predictions, we find out how good our model has been, and we take a decision whether we will proceed further or not. Now you see what I'm doing next is that I'm making a prediction on the test data. Okay, here the prediction was made on the training data, the same data on which the model was created. Now I am giving him data what the model has not seen. So I'm making predictions on the test data, and you see here it is not so bad because in the training data it found R square of 0.54. Here it is found R square of 0.5. Okay, so this is a model which in data science terms we say that this model does not have too much of a bias or variance. A model which has got a lot of bias or variance is not good. Either bias or variance or both is not seen as a model which is something very good. So when we have a situation like that, we have to find out how to reduce the bias, how to reduce the variance, so that we have a stable model which can be making predictions higher. In layman's term, we can say that when either the bias or the variance or both of them are high, the capacity of the model to predict correctly for unknown data will be very minimal. Okay. So I have now shown you the complete process of creating a model. This was a linear regression model. Now I'll go through quickly. We will create a random forest model. So you see here again the process is the same. I scale the data, and I create the random forest regression model. This is going to be stored in this variable. Then I will say fit, where the model will get created. After I create the model, I will predict on the training data, see the scores, and then I will predict on the test data and see the scores. So let's quickly run it. So here my model has got created. So here the predictions what I have created, and you see here now the R square score is around about 0.99. This is a very good R square score. That means this prediction can be very highly relied upon. But let's see, this is on the training data, right? So let's see how good it scores on the test data. Data it has not seen so far. So you see that it is scoring 0.93, which is also not so bad. Okay. So I have taken you through the process of building a model. Do you have any questions? Hello?
Partha, you are considering all the data, right? But now you are taking the sample as randomly, you are taking the sets.
So Partha, so if I understand, we have taken first model, and we were able to get to an R square of 50%.
Yeah.
And we are trying to use the same training data and trying to use the random forest, and then trying to see the same R square to find out, whether the model would be more reliable or not.
Yeah. Yes. Correct. What I have done is that what I have done, just to say, you've brought about a good point. See, I created the training set and the test set, right? I did not do that again and again. I created it only once. Then I create and
correct. And the same has been fed for the previous model and also the current random forest model.
Exactly.
Right?
Yes.
Okay. Right. Okay. Now, I mean, just a basic question. Let's say the previous model or in the current model, if we have to further, let's say, get the R square to be, let's say, 0.99, or I think here it is already 0.99. Let's say in the previous model, what do we generally do in that scenario if we have to increase the prediction?
Yes, very
to
good.
Be more reliable.
Very good question. This is not only true for the previous model. This is true for the random forest model also.
Any model, right? Correct.
Any model. What you will see is that when we start building our models also, initially when we build our model's predictability will not be very good. But we cannot throw that model away. What we will have to do is that we will have to tune that model so that the model's predictability becomes better. Now, there are many ways to increase the model's predictability. Now, in the case of linear regression, for example, in the case of linear regression, in machine learning terms, a very important term is what you will come across as hyperparameters. Hyperparameters are the parameters that we keep on changing so that our model becomes better or worse, right? So to tune a model, what we basically do is that we change the values of the hyperparameters and then check whether the model is improving or degrading. Now, in the case of linear regression, unfortunately, we do not have too many number of hyperparameters. We can have another day where I can discuss linear regression in details with you. This is a interesting subject which can be used in your offices also, but it will take time. So, about half an hour. We can discuss it another day. So
what, in layman terms, what is hyperparameters?
I will tell. Let me take random forest. This will make it clear. Yes, from yesterday's discussion, we understood that in random forest, what we're doing is that we are making a horizontal split of the data, correct? And feeding in.
Absolutely. Yeah.
Horizontal split and giving each split to a different decision tree for
yes.
Right. Also, I am making a vertical split where I'm assigning different columns to each of the decision trees to calculate. Right.
Correct.
Right. Now, one of the hyperparameters it becomes natural to you all is that how many columns in each decision tree should I feed so that my model's randomness becomes higher. I can say that out of these 5 columns, give maximum 3 columns to each decision tree at random. Or I can change that and I say, give at the most 2 columns to each decision tree and let it try to generate the output. So you see that the number of columns which I am feeding into each decision tree becomes a hyperparameter, which I can alter and check whether my model is becoming better or going for a worse case. Do you understand?
Okay, got it. Yeah, okay.
There will be many more. We will discuss many more as we go. I'm just giving you the first hand idea. So, what do you call? I hope it is becoming clear. Okay.
Yeah, yes, Partha. Yes, yeah. You can proceed unless other people have any doubts.
Okay. Yeah, tell me, Senthil.
In another 2 minutes.
Huh?
Meeting about to end.
Okay, another 2 minutes. I now see here Balaji and Senthil and Ranveer. You see, this model is known as the support vector machine model. This is a very powerful model and used in the industry very heavily. Now you see here hyperparameter. You can see here there are 2 hyperparameters. One is C and one is epsilon. I will explain the support vector machine in a different session once again if you are all interested. So you can see here I can change. Okay, let's run this model. Okay. Now you see that I'm running this model, you're getting 85%, right? Now I will change the hyperparameter. I change this to make, let's say I make it 50. And I change this to make it 1.3. Now let me, you see the R square is changing. Do you notice that? Did you guys notice that?
Yes.
So this
Initially,
this is exactly what I'm saying. I'm changing the hyperparameters and the model's behavior, or it will either improve or it will go back. So I have to, this is one of the major tasks of creating models where we have to keep on experimenting for a long time before we reach the right values for each of the hyperparameters.